The following is a formula for the present value of a continuous income stream. Now, in order to explain what the present value is, I'll do a little graph here. We saw in the past that a continuous income stream that's constant like this of $20,000 would grow in a linear way, like this, if we were talking about the total value. And we also said that if we want the future value, we have to consider the interest. So the future value then would be growing like this to an even higher amount than the total value. So you pay in a certain total amount, but you get out much more because of the interest. But in order to understand what the present value is, we have to go back to that formula from the past of A equals PE to the RT. This was a formula for growth of a continuously compounded interest account, and it would grow exponentially. And so, if you invest a one-time payment of P and let the money sit in the account without making any payments or any withdrawals, then it grows exponentially to a higher value. Let's pretend that we had done that in this situation, and I'll put in red here the payment P. And let's say that we put in just the right amount of payment one time so that according to this formula, it would actually grow exponentially to reach the same amount of the future value that we would have got through integration. That's what a present value is. It's the amount of money that you would have to pay right now today in order for it to sit in an account for the same time interval and let it grow to the future value that would have been earned if continuous payments were made. That's a little complicated, but let's see if we can figure it out with some numbers. In past videos, I did say that the total value of this particular account was $400,000. So let's write that in. And I also determined that the future value of this account, according to the integration, would have been about $687,000. All right, so we want to now use an integration to sort of undo the earning of interest and get us back to how much we would have to pay today as a present value to also earn $687,000 at the end of the 20-year period. Okay, let's try it. I'll use the formula above. Present value equals an integral from 0 to n of the revenue stream function times e to the negative RT dt. All right, our present value then is going to go from 0 to 20, $20,000 per year, e to the negative 0.05 t, leave t as a variable because that's the variable of integration here. And I'll just plug this into my calculator. Okay, I get that the present value is approximately $252,848.22. So it's actually, not surprisingly, less than 400,000. Now, why is it less? Why would you have to pay less today than you would have to pay over time to achieve the same future value? The reason is, if you pay now, then all the money has the opportunity to earn interest for the entire 20-year period. Whereas if you make these continuous payments over a span of 20 years, the money that gets added later doesn't actually sit in the account that long, so it's not going to earn as much interest. So that is the meaning of the present value. We also have the relationship here that the future value will equal the present value times e to the RT, in accordance with the formula that we have from the past. And let's just see if it's true. And we'll plug in our numbers that we had. All right, so our future value, according to this, would be 252,848 e to the 0.05 times 20. That's how we calculated it in the past, continuous compound interest. Let's see what we get. Oh, I just noticed this is actually the future value according to discretely compounded interest. The continuous compounded interest value was 312. Okay, so our future value comes out to 687,313. And it checks. 687,312.73.